Hi everyone, this will be a short and hopefully helpful video on how Bayesian network and variable elimination works. So a Bayesian network is an acyclic directed graph where each node has a quantitative probability information attached, such as a table. And any arrow between node X and node Y implies that X has a direct influence on Y. So why is a Bayesian network useful? Well, a Bayesian network can be used to answer any question about the domain, given that the network is a representation of the joint distribution. So this is a really popular Bayesian network example in which your neighbors are supposed to call you if your alarm goes off. As you can see, burglary can cause an alarm to go off, and so can an earthquake. And the chances that the alarm does go off, your neighbor John calls, or your neighbor Mary calls, which are shown in the conditional probability tables next to the nodes. As you can see, the probability of a burglary occurring is 0.001. This is because the conditional probability table shows the probability of an event happening when it is true, in this case, burglary. So when using a Bayesian network to calculate query, we need to eliminate all hidden variables from the equation. For each hidden variable, we calculate the sum of the probability over its possible values, which ensures that the probability accounts for every potential outcome of the hidden variable. So here is an example. The probability of Y, given that event Z has already happened, is equal to alpha times the sum of the probability of all possible values of X times the probability of X, Y, and Z happening. As you can see in the conditional probability formula, the probability of A happening when event B has already happened is simply the probability of A and B divided by the probability of B. But since we might not know the exact probabilities, we use a proportionality constant alpha to normalize the results. So this constant helps us ensure that the final probability sums to 1. So what if you wanted to find out the probability of a burglary not occurring given that John and Mary had both called? We could set this equal to alpha times probability of burglary not occurring and John calling and Mary calling. In order to find our conditional probability, we have to take into account our hidden variables, which in this case are earthquake and alarm. In a Bayesian network, the probability of a joint distribution is simply each variable and its parents. As you can see, burglary and earthquake do not have parents, so we just include the probability of those events occurring. Now, for the probability of alarm, it has two parents, burglary or earthquake, which is why we have to take in the probability of alarm happening given that both burglary and earthquake has already happened. And we do the same for John and Mary calling. Now, one thing we can do here is isolate the probability of a burglary not occurring since it does not depend on earthquake or alarm. And now you have to find the sum of the probabilities of all possible values of earthquake and alarm. To do this, we simply find the probability of each world. Since we are looking for the probability that burglary did not occur, burglary will always be false. For example, in our third world, burglary is false, earthquake is false, and alarm is true. So we simply find the probability that earthquake did not occur, the probability that the alarm went off and an earthquake did not occur, and that the burglary did not occur, the probability that John called and the alarm went off, times probability that Mary called and the alarm went off. After you plug in each probability, you multiply all the probability of a world and sum the results of all the worlds together. And that gives us alpha times 0.0014919. So I've already found the probability of a burglary occurring when John and Mary both calls, which is alpha times 0.000592224. So by adding both values here, we can find the alpha that we need in order to normalize our probability. So 1 is set equal to alpha times 0.002081414, and if we do 1 divided by 0.002081414, we will get an alpha of 479.8142. Finally, we do alpha times the result, which is 0.71583. This means that there was a 71.58% chance a burglary did not occur when John and Mary both called.